Hey friends! Well, transistors aren't over yet. eCraft Geeks brings you FET, Field Effect Junction Transistor. The field effect transistor is a transistor that uses an electric field to control the electric behavior of the device. Many different implementation of the field effect transistors exist. Field effect transistor generally display very high input impedance at the low frequencies. The FET consists of a semiconductor channel with electrodes at the either end referred to as drain and the source. The control electrode called the gate is placed in a very close proximity to the channel so that its electric charge is able to affect the channel. In this way, the gate of the FET controls the flow of the carriers, flowing from the source to the drain. It does this by controlling the size and shape of the conductive channel. The semiconductor channel where the current flow occurs may be either P-type or N-type. This gives rise to two types of categories of FET, known as P-channel and N-channel FET. The electric field to control the current is applied to a third electrode known as gate. As it is only the electric field that controls the current flowing in the channel, the device is said to be voltage operated and it has a high input impedance, usually many mega ohms. This can be distinct advantage over the bipolar transistor that is current operated and has much lower input impedance. The external field on the gate may serve to deplete the channel of the carriers, in which case the FET is known as depletion mode FET, or it may serve to enhance the carrier in the channel when it is known as an enhancement mode FET. There are various types of FETs, but two main types are JFET and MOSFET. There are many different types of FET on the market for which there are various names. Some of the major categories are junction FET, also known as JFET. As the name implies, this form of FET uses a reverse bias diode junction to provide the isolation from the channel. It is the most basic type of FET and one that was the first developed. However, it still provides excellent service in many areas of electronics. Insulated gate FET, also known as metal oxide silicon FET or MOSFET. This type of FET uses an insulated layer between the gate and the channel. Typically, this is formed from a layer of oxide of the semiconductor. The most common type of IGFET, the MOSFET metal oxide silicon FET. Here, the gate is made of a layer of metal set down on a silicon oxide, which in turn is on the silicon channel. VMOS. VMOS standard for vertical MOS. It is a type of FET that uses a vertical current flow to improve the switching and current carrying performance. VMOS FET are widely used for power applications. There are few other types like dual gate MOSFET, MESFET, HEMT or FEMT and FinFET. Main FET specification. The datasheet includes some of the FET specifications, some of the important for JFET while some of for MOSFET and others. Gate source voltage VGS. The FET parameter VGS is the rating for the maximum voltage that can be tolerated between the gate and the source terminal. The purpose for including this parameter in the datasheet is to prevent the damage to the gate oxide. Drain source voltage VDSS. This is the rating for the maximum drain source voltage that can be applied without causing avalanche breakdown. The parameter is only stated for the case where the gate is shorted to the source and for temperature of 25 degrees Celsius. Depending on the temperature, the avalanche breakdown voltage could be actually be less than the VDSS rating. Threshold voltage VGS-TH. The threshold voltage VGS-TH is the minimum gate voltage that can form a conducting channel between the source and the drain. It is normally quoted for a given source drain current. Gate source cutoff voltage VGS off. The gate source cutoff voltage is really a turn-off specification. It defines the threshold voltage for a given residual current. So the device is basically off but on the verge of turning on. Drain current at the zero gate voltage IDSS. This FET parameter is the maximum continuous current the device can carry with the device fully on. Normally it is specified for a particular temperature, typically 25 degrees Celsius. The actual switching current should be limited to less than half of the IDSS at TC is equal to 25 degrees Celsius rating in a hard switched application. Input capacitance CISS. The input capacitance parameter for a FET is the capacitance that is measured between the gate and the source terminal with the drain shorted to the source for AC signals. In other words, this is effectively to the capacitance between the gate and the channel. This can be expressed as CISS is equal to CGS plus CGD. Drain source on resistance RDS on. With the FET turned hard on, this is the resistance in ohms exhibited across the channel between the drain and source. It is particularly important in switching application from logic to power switching as well as in RF switching, including applications in mixers. Power dissipation PTOT. This FET specification is the maximum continuous power the device can dissipate. It is normally specified in freestanding in air or with the base held at the given temperature, typically 25 degrees Celsius. Why FET? When you have BJT, BJT has high voltage gain, FET has low voltage gain. BJT low current gain while the FET has high current gain. The input impedance of BJT is quite low. The FET has very high input impedance. Low output impedance of the BJT compared to FET. FET has high output impedance. The noise generation of BJT is medium, while the noise generation of FET is quite low. The switching time of the BJT is medium, while the FET's switching time is faster. BJT is robust, but the FET can be easily damaged. BJT requires zero input to turn it off. Some need an input to turn it off in the case of FET. It is a current controlled device, the BJT. It is the voltage controlled device, that is the FET. The BJTs are cheap, the FETs are more expensive compared to BJT. FETs are difficult to bias while BJT are easy to get biased.